and welcome to yet another inspirational episode of Beyond Her Shodh. I am your host, Dr. Sonia Balyan, and today I am honored and thrilled to have a well recognized, passionate woman biologist, a leader of Indian science, and a huge inspiration for all the ambitious women out there, Professor Chandrima Shaha. Professor Shaha is currently working as J.C. Bose Chair Distinguished Professor at the Indian Institute of Chemical Biology, Kolkata. She is the first woman president of the Indian National Science Academy. She is also the former director and former professor of Eminence at the National Institute of Immunology. She is the first women cricket commentator of All India Radio, also the vice captain of West Bengal's first women's cricket team. And more importantly, her group was the first to show that programmed cell death exists in unicellular organisms. Her research interest geared towards the understanding of cell death pathways and cellular defense processes in unicellular and multicellular organisms that have an important bearing on designing of therapies for various diseases. Also, she has done extensive research on Leishmania parasite, which causes Kala-azar, a fatal parasitic disease in humans. She has a long list of awards and recognitions in her name, including Shanti Swarup Bhatnagar Medal INSA in the year 2019, Lifetime Achievement Award in the year 2021, Dr. S.P. Ray Chaudhary Endowment Award Lecture from the Society of Cell Biology India in the year 2020 and 2021. Professor Shaha has successfully held several respectable and responsible roles in the field of science and education. She has been an active member of several prestigious academic and scientific societies such as Indian National Science Academy, the Indian Academy of Sciences, and the National Academy of Sciences. He has been the active member in various task forces.
Honor and privilege to welcome Professor Shaha to Beyond Shodh. A very warm namaste, ma'am, and we express our sincere and cordial welcome to you. Thank you so very much for joining us today. Thank you so much, ma'am.
Welcome, most welcome. And I congratulate you on initiating this program.
Thank you, ma'am.
So that we can reach out to young women scientists.
So, ma'am, my first question to you is, you have had a remarkable career in biology and covering diverse fields from reproductive biology to cell death and then in parasitology also. Can you please share with us your research interest and vision all through your journey?
Yes, my interest in cells actually came when I first time peered through a microscope, which was pretty much when I was pretty much young, maybe in my school days. And then eventually when I started my career in research, and that was in the early 80s and late 70s when the field of cell death was actually exploding. So somebody has described cell death a little while before that. So then I became interested in cell death and started working in it. And so for the first model that I used was in my laboratory was the germ cells. As you know, germ cells are the progenitor cells that are used for reproduction. And so the body produces a lot of germ cells, both in the males and females. And so what do you do with so much germ cells? So there is about 75% of these cells that die by the process of cell death, called a programmed cell death. And so this is a very important model to study cell death. And so we use the germ cells, and we were generally looking at cell death in cells with high division index. So we were also looking at the parasites. The parasites also, they are clonally they are reproducing, and so they have cell death, which we reported many years back, as it was sort of first report that a unicellular organism has something called an apoptosis-like death. So, and we asked many important questions like, when do a cell actually initiate a cell death pathway? And is there a point of no return after when the cell actually starts dying or attains death? And why do some cells survive and some cells don't when you give a toxin? So there are multiple questions that we ask. And that is how, the vision to study cell death evolved.
And then, ma'am, you have also contributed to the disease called Kala-azar.
Yes.
So how that came into your research?
Well, when we were doing the parasites, the model I was using was the Leishmania parasite. This disease, this Kala-azar, is endemic in certain parts of Bihar, and it is in many, you can find that the cutaneous form in many places in India now. So, what is said is that the incidence of actual Kala-azar, which is a visceral form of the disease, which is fatal if not treated, is actually less now. But there are a lot of cutaneous form, which is called post-Kala-azar dermal leishmaniasis. Those patients are around, and they sort of serve as a reservoir. So any favorable condition of vectors, any favorable condition of immune compromisation can lead to leishmaniasis. So it is not that leishmania is the incidences are lowered and we can sort of rest. It's not like that. It's we have to be on the vigil all the time. So when we were doing parasites, we're using this this model, and that's how we got into actual leishmaniasis. But our aim was to look at the biology of the parasite and to identify how the parasite works, how the parasite biology works, and when does it die, when does it, when it is dividing, what are the situations. So eventually what we did was we identified certain targets that can be through these study of these mechanisms, and these targets we have suggested some drugs which are mainly repurposed drugs used for cancer. And that those are in trial now. So these can be used for leishmaniasis, because leishmaniasis treatment is very expensive and it is beyond the reach of the poor, who are actually affected mostly by it.
So, ma'am, what is the status of this disease presently in current scenario?
Yeah, as I'm saying that the actual incidences of visceral leishmaniasis has gone down because of very effective vector control and then treatment and better nutrition. So that has lowered the incidences down. But there are a lot of cases of post-Kala-azar dermal leishmaniasis, which is a skin form of infection. And that actually, what it does is it stays there. It doesn't make you too sick, but it stays there, and it can act as a stimulus to for visceral leishmaniasis to develop. So we are in that stage that we have to be on the vigil all the time so that this doesn't happen.
So, ma'am, how this cell death can be a critical factor for any person's health?
So, see, cell death has a very big physiological significance, because when we are born, we are conceived as single cells, and then it multiplies and becomes round ball of cells. Now, if it kept on dividing like that, we would only be a round ball of cells. We will not have hands and feet. So eventually what happens is, with all the programmed events that take place, it's like a sculpting. So cells die to sculpt out the organism. So imagine a sculptor sculpting a piece of stone with his chisel and giving it a shape. So it's something like this, that physiologically cell death is important because it gives us shape. And it's also important for the organs, for the organs to form. So if there are abnormalities in this, there are issues with health. So this is one part. This is the physiological part. The second part is that it is linked to disease. So if the cell death pathway is turned off in a cell, then that cell is immortal. And if it is immortal, it starts dividing, propagating that mutation, and that's when we get cancer. So that is one thing. Then in case of neurodegenerative diseases, if a lot of cell death is there, the brain, does not function properly. So there has to be a very critical balance between the cell death and cell division, because we every day in our body about 10 to power 11 cells die and 10 to the power 11 cells are born. So in a given year, we lose cells as much as our body weight. There is so much cell death. So cell death in this way is very important for us.
And especially, ma'am, for cancer, in the treatment of cancer and
Yes,
that
there are targeted therapies now that target the pathways of apoptosis so that they are not switched off, or even if they're switched off, you generate a different pathway. So there are many targeted therapy evolved after the apoptotic death pathways were discovered.
So, ma'am, in Kolkata also, you are following the similar research interest, or now you are working on some other aspects also?
No, mainly I'm following the same pathway that I have done all my life. I mean, looking at cells and, learning more about cells. So learning never ceases. So one has to keep doing that.
Sure, ma'am. And amazing work. And I've read uh, your interviews, and they were so fascinating that I keep on reading, and then I'm waiting for when I got the chance to, just ask my questions to you. So, ma'am, it's a belief of me that every tall building needs a very strong base. And so, how did your childhood upbringing, your family values, shaped you as one of the top leaders of the Indian science community?
See, my childhood was a little different from the childhood of my contemporaries, of my, school friends or so, because I was born to parents who were nationalists, who were freedom fighters, but both of them were artists. So, that's, and, when both person are creative, there is a lot of energy around. So it was a household charged with energy all around. And so it was kind of sometimes difficult to, manage, because two people are creative and they're, but I was given the freedom to do anything I wanted. And I did many things when I was young. I took to photography, and I would do take trips to photograph, and then I would come back and use the darkroom to develop things. So I would learn about photography. Then I would be collecting insects all around and making a museum in my house. So I had a pretty much independence, except that my mother never wanted any snakes, which I also had.
You never got afraid of these insects?
No, I wasn't. I mean, you learn how to handle them. And so snakes also I brought home, and my mother was not happy with that. But so I had a very unusual kind of, upbringing. And then, as you mentioned, yes?
You are the only child, or you
Yes.
have siblings also?
No, I was the only child.
Only master of the house.
Yes. And then as you mentioned, that I started playing cricket as a part of interest, because my father sort of tried to give me a holistic education. He tried to create an interest in science in me, although he wasn't a scientist himself. But he brought me a telescope, he brought me a microscope, and then he got me interested into photography. I had to swim. He taught me swimming. So I learned a lot of things when I was young, and eventually I played cricket and represented the state and became the vice captain of the team, which in a way later in life, that lesson became very important. Yes. Because that helped me, in my science, in the sense that teamwork, the diligence, science is like a game of cricket. I mean, sometimes you catch, sometimes you leave a catch. So science is very much like that. So that helped me in my life later on.
So, ma'am, you have the passion for photography. Your mother Mrs. Karuna Saha. Correct me
Yes.
if I'm wrong.
Yes.
She was a renowned
Painter.
painter at
Painter.
at her times. So,
Yes.
did you also like to paint, or also has interest towards that painting?
No, initially I started, some painting as I was dabbling in many things as a part of my interest, and I was doing some painting, but my mother wasn't too encouraging about that, and I was also so because struggle for an artist was much more at that time,
Yes.
and my father was also encouraging me to do science.
Mm-hmm.
So then that interest, I left at that point.
And there, on the internet, I found several biography of your father, Shambhu Saha. Uh,
Yes.
there I read that he's associated with Dr. Rabindranath Tagore.
It was much before I was born.
Okay.
So he, because Tagore died in 1941.
Mm-hmm.
And so before that, my father was with him and has a record of
Early
his
days.
life. Yes, early days. Yes.
Mm-hmm.
So, but Tagore is a part of a Bengali household, Bengali mind, Bengali psyche. So Tagore is always there, and to almost all Bengalis.
Mm-hmm.
But so he was associated with him. Yeah.
So, ma'am, any other inspiration or person beyond your family who really inspired you to take up science as your career?
You see, when we were young, that I'm talking again about the 70s, 60s, in fact, there were not too many biographies of women scientists of India. So Marie Curie was the only example of woman scientists that we were looking at. There are others also, Lisa Meitner and others, but those were generally I read and had some inspiration from there because I wanted to do science. Later on, we came to know about scientists like Janaki Ammal, but these were much later. Ashima Chatterjee was a figure in Kolkata, being a very renowned chemist. So no one in particular really I followed but they were all very inspiring, these examples, because they were very peculiar to themselves. If you talk about Ashima Chatterjee, if you talk about Janaki Ammal, if you talk about Marie Curie's contribution was phenomenal. I mean, in a world, she changed the world, literally. So those were inspirations, I would say.
Now, any difficult times or any other incident you remember that, okay, this could be the hurdle in my journey, or some incident that you remember of your initial days when you started your career in science?
Um, you know, hurdle in that sense, I never had in that. If you talk about hurdle in that sense, hurdle was science itself. I mean, in the sense that sometimes experiments work, sometimes they don't. So those were the little hurdles that I really encountered. But if you talk about hurdle professionally, I really never really experienced that, because I was performing with passion, and I also thought that these you are being efficient, you are being diligent, you are being creative, has no gender. So there I didn't face any problem. But having said that, I realized while going through my journey that there are many hurdles for women.
Yes.
And there are many, and those need to be addressed. So and so the people around has to be sensitized. It is not only the woman that matters, it's the surrounding society also matters very much. And so that's what also I realized. And those situations again are very peculiar, because I have a journey which was relatively smooth, maybe. Others may have a journey which is full of struggle. So little struggles that I had, I don't think I can, they're not worth really mentioning. But there are problems. I realize that.
So, ma'am, do you still play cricket?
I know. I'm
No?
too old for that.
No, ma'am, you don't have to.
No, I'm too old.
And any other sports that you are interested in?
Other than cricket, football, yes, I watch a lot of football, which I got interested pretty late in life. But cricket has always been a passion, even for from the very young days.
Or any incident or discovery that could be acted as the turning point of your career? Any significant point where you felt that?
Actually, our discovery that cell death occurs in unicellular organisms was kind of a turning point for the laboratory, because then we started seriously working on the model of parasite. And it was an exciting time, because that's a very important evolutionary question, that if a single cell dies, what is the purpose of evolution? Because the purpose of natural selection is to help a species survive. So that way we try to do many experiments to answer questions is why it should be there in single cells, and we arrived at certain conclusions. And that, I would say, was a kind of turning point for us, because when we discovered and started working, and that I remember was a very stimulating time in the laboratory that happened.
So, ma'am, is it any previous knowledge already there, or your group is the first time who showed this phenomena in unicellular organisms?
Yeah, we were actually able to show the characteristics of cell death in the unicellular organism, which was not shown before. And that's how, but ours was probably the first report of showing the characteristics, but there were one or two reports, very few, of possibilities of cell death being there in unicellular organisms. But then many papers have come out, many elegant studies have come out with that why evolution would favor such an event. So that was the turning point, yes.
So then onwards, this is the main interest of.
This was the main interest from my laboratory, and we continued looking at different mechanisms and how can you use drugs which are currently in the market to sort of kill the parasites. And we used some animal models to show that these drugs can be used, repurposed and used.
Very interesting. I'm going to say that it is an interesting phenomena to work, and getting so many leads is again phenomenal. Ma'am, coming to your role, and you have played an active role in promoting science education outreach in India. You have also been involved in various academies, council task forces, and editorial boards related to science policy and communication. So what are the areas that need improvement in the Indian research scenario, and what all new policies can be framed to improve that and to involve young minds into research?
See, there are many forward-looking policies of the government, and especially I would say that we have many women-friendly policies. But if you look at the literature or the data, you'll see that about 40% people go into science, 40% women go into science. A lot of them are coming. We are teaching a lot of them, and we're training also a lot of them. But then what happens is after PhD, you see to drop off about to 15%. Then as you go further into jobs, you see about 10%. Then if you go to leadership, then it's about 2%. So it gradually keeps on falling. So I think the most important thing, one is that the critical mass is still not there, and the most important thing is to prevent the fall. Why people are going out and how can we help them to stay in the profession is the thing. So there are this is a very, very complex issue. So there are multiple things that one needs to address. And the women-friendly policies of the government, like, for example, coming back after a break in service, and all these have helped. But then we have Gati, which is the gender-friendly program for all the institutions to have gender-friendly, women-friendly programs. So with these, I am sure that we are going to improve, but this is not sufficient. I think we proactively need to monitor how institutions are actually administering these, because just taking an oath or just taking making a charter doesn't help. one has to monitor. Everything needs monitoring. We are not monitoring. And if you look for a creche, or if you look for a woman's room or something, very few institutions will have. But this is the mandate of the Gati, is to have all, because you have to help the women. And the misconception is why women should get this help. The thing is, the family consists of the man and the woman and the child, so if the woman has to be comfortable, she needs policies that would support her. So I think one is that. The other, I think, is to increase the money in science in general, because it's a dismal percentage of our GDP that we have in science. So if if money comes in, and we can increase the diversity of having women more into the mainstream, then we have diversity breeds innovation. In a way, diversity will help in getting many points of view, which is important for any country to go up and improve itself. So I think what we really need to do is, one, to get the money increase the money for our total GDP, and the other thing is to sort of see if women can be given institutional support. And one more thing that I would like to say here is that revamp our university system, because it's the universities which nurture the students, and if the research there is helped by money, helped by mentoring, helped in many ways, they should be given resources, we would go a long way in getting the young minds interested in science and doing science. I think university system is something that we really need to upgrade.
If we have equal representation at the higher level also, I think then these key areas, which is a problem for a woman, and can be brought up and maybe solved with some solutions.
I think we are all sensitive to the fact that flexible timing is very important. Sometimes it goes against a woman also.
Yes.
Because I'll tell you, the child care leave, it has been misused by many. And that people are not willing to take women because of these things. So, there has to be a balance. So I think while we try to develop our policies, we should have more women in those committees, because the women's problems are understood by women only. So we should have more women actually talking about these problems and trying to have policies that will not hurt the work and not hurt the individual, but have something which will eventually evolve into a good journey.
So, ma'am, in your lab, what kind of ecosystem you have created for all the students? Is there any cases where you have granted some flexibility to women, especially?
I am virtually at the end of my career. So the entire career I've had a laboratory, and there I had many women coming in, both married and unmarried, right? So the married women required some kind of today I have to go, to my children are going to school, and I have to have a parent-teachers meeting like that. So in science, what happens is, you manage your own time, you take off. So I have sort of gone like that you get your work done whatever time you feel like, and I didn't want people to be stressed, so they can relax and do that whatever time they would require for their own work.
Yes. Actually, this one support is very necessary. So, because if you are interested in your work, you will complete it.
Yes.
Whether you are now you have sleepless night to complete it, it's now your work, and this is your responsibility to complete it.
So to my surprise, it has really worked. Because they would get the work done. They're not stressed. So to my surprise, it has worked. I think that kind of attitude would also go a long way in encouraging women to be, women get very apprehensive. Is if I get into a laboratory, I will not have time to do this at home, do that at home. As you are saying, that they just leave. So if they are comfortable in the laboratory, knowing that they have the time on their side, I think that will help.
Yes, yes. Because sometimes they don't even give it a try. They have
Right.
their in mind, they have make a no, it is not possible.
Yes.
So
Yes.
there, the inspiration from leaders like you came into picture that it can be possible. You
Yes.
just have to start,
Yes.
and any start can become a journey to reach.
Yes. Yes.
So it's important, ma'am, and I think women scientists who are and any girl which is aspiring to be a scientist will listen and make their mind to make a career. No problem. I usually have that after PhD, everyone just wanted to go abroad for postdoc. How much improvement our Indian system needed, or what all measures we need to become India a destination or a choice for national as well as international students to come here and pursue their passion for research.
See, this is a perennial problem that has happened from many, many decades, I would say, since the 60s. People
Hmm.
started going out, and because there were not enough opportunities, not enough infrastructure. But if you talk about infrastructure, any laboratory now in a decent institute are well equipped as the
Yes.
US laboratories. So
Hmm.
it is not that draws people, I would say.
We are having very good publications from India in
Yes,
top reputed journals also.
yes, yes.
So the system is improving, but what all we still need to do in this area?
My personal opinion is that people who want to go abroad, I mean, they should be given sufficient incentive to stay in the country.
Hmm.
Now, in what form that incentive is if they're interested in work, they would look for sufficient grants, they would they would want a good working atmosphere, and that they can get. But if they go to US, they have a salary by which they can do certain things which is not possible in this country. But I mean, I would say that life in India is more comfortable than if you are in the US, in the sense that you don't have to do everything by yourself
Hmm.
here. And it's still, you have this advantage of being a little relaxed in this. So it has happened during my in my laboratory, that people who have not gone abroad, they have not gone abroad, they have stayed in India, but most of them have joined industry. The
Hmm.
reason being that industry salary is much higher,
Yes.
and they are not getting a mental satisfaction because they cannot be academicians. But then they stayed back. So I think we need to provide them with incentives that will force them to stay in the country. That if, then what you can do, you can always go for a sabbatical, you can always go abroad for meetings and all. So that is always there. But if you want to live a life in India, I think it's a good life here. It's not,
Because ma'am, you have experienced both.
Yes, I have. I have gone many times
Hmm.
after I came back,
Hmm.
and spent quality time over there for like 3 months every year for 16 or 17 years. I have gone there. So I thought that, I had a good life in India
Hmm.
as compared to what I would have. But, opinions differ, experiences differ, choices differ.
Hmm. So, ma'am, uh, my next question to you is you have an objective to counter pseudoscience.
Yes.
I've read in your previous interviews. So how do you define that concept and how it can be achieved?
I think pseudoscience is something that is believing in something without scientific evidence.
Mm-hmm.
One thing that I have felt that we have failed to do as scientists, perhaps, that we have not told people that what is the process of science.
Mm-hmm.
I mean, we have told them that we require vaccines for COVID-19. But how arriving at a vaccine, what do you need to do for arriving at a vaccine? So everybody was impatient as why tomorrow there is no vaccine.
Mm-hmm.
So that process or what evidence you need to support your, whatever observations you have made, we have not taught people. And that is where the problem comes in. Because if you understand the process of science, if you understand that evidence is required to believe something, then, this tendency to believe in things which are not provided by evidence, which are not proved by evidence, comes. So I think that is the way we need to, through science communication, teach people what are the processes that science takes and why we need to believe in science. Because we are surrounded by science and we are surviving because because of the scientific developments that has happened. And we are performing because of the scientific developments. But there is a process to that. And so we need to believe in things which, for which there is evidence. So, for example, if you talk about the removal of the Darwinian theory of evolution from the books, it's because people have not understood the process. That what kind of evidences do we have? What do we need to look at? So I think it's required. This is required.
Yes, yes. In certain very easy way, how people can understand these scientific terms or scientific processes. It is necessary. So, what exactly is needed uh, to uh, to spread that kind of outreach, ma'am?
I think it's only science communication that will help. Unfortunately, in our country, we do not have mass programs that people can come and listen to scientists. And there was a program in the US called Origin. And that Origin was attended by 3,000, 4,000 people at a time with, popular science people were speaking about popular science, speaking about science. And I think that is because we have a lot of people who do good popular science.
Yes, ma'am.
They can communicate with the mass. So if we have these kind of meetings, we can actually instill in people that there is evidence necessary to believe something. And to believe, what is happening around us and why it is happening. What do we know about it? How much evidence is there? Like that. So we should be questioning. We should be questioning things. Query is the main basis of science.
Yes.
All these things needs to be communicated.
And actually, you are also associated with Science Setu.
Yes.
So that was a very good initiative. I think community is benefited from that. How that idea came into your mind that we must have some program like this?
So when I was the director of National Institute of Immunology, we were thinking of how to, because we were pretty much within ourselves, that how to reach out to students, how to reach out to colleges where they are sort of not very raw but a little bit mature. They are not in school.
Yes,
so we started looking at colleges and asking them to join the science set, and our scientists would go and lecture them. They would even take their microscopes and other equipments to show them They would invite them to the laboratories. Then we would have garden walks like inside NII, so that someone will talk about what are the importance of the trees that we have, how medicinally they may be important, or otherwise what is the behavior of the tree, when does it flower. I mean, in general, it questions interest in science. And that became very successful because students were so enthusiastic. They were really enthusiastic to know about science and all. This was a revelation to me that so many students were so interested. So that's how we sort of conceived the idea of science check when we started doing it through the colleges, and now I believe that others are also doing it. So it is important for us scientists to get in touch with young students because we can be a source of inspiration for them. We can tell them what is evidence, what is science. We can show them the wonderful world of science because in all my journey, what I have experienced is that you are looking at life up close in the laboratory, which not everybody can do.
Yes.
So that is the pleasure that you have to be a scientist. It is actually looking at life, how life works up close. So I think that excitement, if it can be conveyed to the students, because you see, we are getting lesser and lesser students in science because of so many other reasons. So if you can convey that message, I think we will be doing some justice to our,
Yes, sure, ma'am. Because that was a very good initiative. In NIPGR also we have such programs where the school students came and they visit the laboratory. Because in school they don't have the access to instruments like this is the instrument which in books you are seeing in books pictures, and practical knowledge is something which really teach you at every. So everything doesn't goes into your mind by reading. So in science especially we need practical expertise.
Yes.
So ma'am, is any other interesting idea that is in your head and that should be a policy or in certain way that could benefit the young minds and increase their involvement in science?
I think, I don't know if it is practically possible to do, is to have interactions with the students. So, suppose in a metro or even in a rural setting, like here we have programs, there are some, NASI has done some programs here with going into the remote areas.
Okay.
And so they do not have access, but they are so interested in knowing about things. So I think if we can increase interaction somehow in public forum, like I'm talking about the Origin program in the US that invited people to a public place and scientists talked about their work or making it very interesting. And so I think if that could be taken up, So even, I'm not talking about only school children or college children, even the society in general and in the general public, that also gets into them. So that I think can be something that we can think of doing.
Something like science for all. In easy language. Easy language which any layman can understand.
Yes. And they can understand and they can know that how, suppose there is a disease and how we tackle the disease, and it is not that, everything is magic and everything needs a course of time to develop a drug, to test. So all these information for people and showing them what we can know with science. You see, if you see very recently that this telescope, James Webb Telescope, Space Telescope, has sent out images to us, which is looking at several million light years ago that what happened in the universe. It's almost looking at the creation of the universe. So science can, with that, look at that also. And there was a very recent report that how this sun in one of the galaxies, it is eating up the planets. which is the eventual fate of Earth, maybe many billions of years later. But these are very interesting things that one can know. Even, by stories, by telling stories to little children, that what is happening in the world of science.
Maybe some in national channel or something, if there's some program which address these simple issues and in simple language to
Yes.
the students, that would be good.
I think telling them stories is a good idea. Stories to the children, because they, whatever age they are in the young days, we used to listen to so many stories. We didn't have the television. I'm talking about my young days. I never had a television. Television was not there. Only radio was there. And we used to listen to radio. We used to listen to our parents. We used to listen to so many people telling stories. Those days are gone. But I still think that these kids are interested in stories.
Sure, ma'am. There must be some innovative way of teaching them and, inspire to be in science and make your career in science.
Yes.
Finger crossed, we see some good programs for that. And, ma'am, so what is your advice to aspiring researchers who are listening to you?
Well, to aspiring researchers, I would say that first they should find out how much passionate they are about their goal. And so because science is a very, very different ball game.
Yes.
So if they're passionate enough, they choose the profession. But there may be hurdles. So in that case, what I suggest is two things they can do. One is they can select out role models. Modern role models, not role models of yesteryears. Of course, we need role models of yesteryears for inspiration, but modern role models who they can relate to and contact, and even talk about their own problems, and sort of get ideas of that, and not to get disheartened in case there are some failures, because we all have experienced failures in a different way. And so they should not be demoralized. So that is one thing I think is my main message, that first identify your own interest, then go through it. There will be struggles, there will be failures. There may not be failures, but there may be failures. So learn to address that and then go through it. Find out mentors. Find out role models. These are important things because they help a lot. Because if you can identify with a person who has undergone with similar kind of difficulties, then you can speak, ideas come out, situations you are more, familiar with. So I think these are the things that the young aspiring young scientists should do. And above all, I would say that be passionate and work very hard to get to your goal. Because in science, like every morning you go, it's like you're going to do something new today, and by evening you're failed. So then you get up next morning, I'm going to improve on that. So life is like that in science, and one should be aware of that. And I think that way you can go much higher and higher.
So, ma'am, what was what is your motivation or inspiration in all these years to be in science with so much of passion? What exactly is the main strength behind?
What I believe is different people are driven differently. And I am a very self-driven person because from my young age, I wanted to do something because, I got into this photography and going to different places because our college was closed for almost 2 years because of the Naxal-like problem in the early 70s. And so I had to do something else. It's not that I would just sit around and read books and spend my time. So I am a very self-driven person, and that has been my self-motivation always to do something. And I hope I can maintain that rest of my life. But that is something that gets difficult when you get older. But I have been very self-driven.
So, ma'am, are you satisfied with the legacy that you have created? or something else is still left?
No, I don't. I think I could have done much more.
Okay.
And so it's not that I'm satisfied, but only you can do only so much. But I'm not satisfied with what I've done. I think I could have done much more.
Okay, ma'am. So any plans for future?
Future is now, as I told you, I've reached virtually the end of my career. So now you have to give your experience to others. And that's what I've been doing, talking to younger people. And of course, I'm sitting in many committees, sitting in many meetings. And there also I give my expertise. So this is, I think, future is about now. But once you reach a certain point.
But how do you see so many years of journey, ma'am?
I think it has been a very satisfying journey in the sense because all throughout I have had great fun.
What is the best part of it, ma'am?
The best part was that laboratory because the laboratory was like a family and training students and arguing with them, loving them, and helping them. So that was the best part of the entire journey.
So now here in Kolkata, do you miss NII?
Not really, because this is the institute where I did my PhD.
Okay.
So I made a full circle. I went from there and came back there. So I have many old friends, and I have my cricket friends, I have my college friends, I have my school friends. So the entire social setup is here. So it's not that I of course the life I have spent 37 years in NII. So
37
it's something.
Years,
37 years.
Wow.
So it's not that I will not miss it in that context, but because I still can go back sometimes and be there. I've been there since I've left. It is not like it's hurting me, but it's been a very nice experience, the whole NII. And so much time in a place, you would get attached to the place. But then this is my home also. And so it depends, as I said, it depends on your psychology, how you take the thing. And so I think I was happy there and I'm happy here. So
and now you can also restart your cricket journey. You can.
I don't think I will do that.
Ma'am, because you have your cricket friends with you, so you can start.
No, I don't think my mind is set for that because I've done too many years of science. And so cricket interests me, but not to get involved in that again is a little difficult.
Beyond research, you found your passion in?
Yes, my research.
Beyond research, what is your second passion?
Beyond research. Yes, it's the life in general. As I said, I enjoy doing many things and reading. And my interest in reading is many good biographies because especially my passion, you can say, in reading biographies because that gives you a contemporary history of a time and also it tells you about a person. And there are so many different people with different psyche. So I like to do that.
Ma'am, your favorite book?
Favorite book, I would say this book by it's Charles Darwin's not Origin of Species. It's about Darwin. The Greatest Show on Earth by Richard Dawkins. Yes, it's about Darwin's work.
So, ma'am, if you are not a scientist, what would you be?
If I'm not a scientist, what I would do? I had so many choices. Difficult to say. So,
anyone or two.
I would certainly not be a professional cricket player, but I would probably use photography to study society.
Your biggest cheerleader?
I don't know. Who is my biggest cheerleader? My students, probably.
Ma'am, your inspiration from science fraternity?
My inspiration
Yes.
from science fraternity that I am in.
Yes.
My colleagues, my scientist colleagues, they are my inspiration.
Ma'am, any other specific name which you want to?
No, I would not like to tell. Okay.
Your favorite student? This is the tough one. I think you will skip it.
All of them are my favorites in one way or other. And later on, I tell them that how much they bothered me or how much they, gave me good times. So it's difficult to name anyone.
Ma'am, your favorite food?
Food. It's luchi mangsho in Bengali. Bengali food. Luchi means puri, made of maida and the meat that goes with it. That's my favorite.
Do you like cooking also?
No.
No.
I can't cook.
Okay. So, in your view, who is the better teacher, success or failure?
Failure. Failure is a better teacher. Success sometimes gets into your head, but I think failure teaches you how to actually conduct yourself and bring it to a success.
Okay. Fair enough. Favorite journal?
Journal meaning you mean science?
Science journals.
Well, nature, science. These are the journals that gives you every day the progress of science.
Describe your journey in one sentence.
It's been a great enjoyment looking at life, as I said, up close.
And ma'am, what would be the title of your biography?
My biography. I haven't thought about that. How would it? I haven't thought about the title of my biography. It would be something. No, that in rapid fire I cannot answer.
So forget, ma'am. This is the rapid fire. Now answer.
No, even one has to think how a biography would be. When we chose the name of my mother's biography, we had a lot of thought going into it. It finally became in her own right. So it was in her own right. So I'll have to think about it. If at all there is a biography.
Ma'am, there will be, yes. One goal that you still want to achieve?
I think I want to reach out to many students, which I have not really been able to do being in an institution where you are not exposed to MSc or BSc students because we never taught them. And so one of my aims would be to reach out to them and talk to them. This is one thing.
Very interesting thought, ma'am. Very interesting.
Yeah.
Yes.
Because we have not, in our institutions, we have not, only with Science Setu we could reach out to some of these children. But otherwise, not en masse.
Yes. So thank you so much, ma'am, for your time.
You're welcome.
I think I have exceeded the time. So, it's 12:27. Thank you so much. Thank you so much.
Welcome.
Thank you so much.